Hi calculus students. Today we learned a new rule called the chain rule. The chain rule is a rule that we use when we have a composition of functions, so a function inside of another function, and we have to follow this derivative rule, where we first take the derivative of the outside function, the inside stays the same, and then we multiply by the derivative on the inside. And so a simple chain rule might look something like example 5, which I think is easier done to rewrite with a -1 exponent. And I could think of 4x minus 3 as my inside function, and this -1 as my outer function. So then when I apply my chain rule, y prime, I'll take the derivative of the outside, would be -1. My new exponent would be -2. So there is the derivative of the outside. My inside function stays the same. And then I multiply times the derivative of what's on the inside, which is 4. So blue is the outside work, pink is the inside work. And then do a little simplification. We always want to make negative exponents positive. So I will rewrite this as -4 over 4x minus 3 squared. And that's it. So if we flip to the back, we're going to see more challenging problems. So we still have our 3 basic rules: power, product, and quotient rules. And the chain rule is not really a basic rule of differentiation because chain rule is always in effect. So no matter what derivative you're taking, technically you're using the chain rule. And so when we're labeling these about which rule we're going to use, we don't really want to think, are we going to use chain rule? Because you're probably going to use it either way. We still want to think, is this power, product, or quotient? Or going forward, we're also going to have ones where is this, not sine, is this trig? Or is this an exponential, e to the x, or ln of x? Okay, so we still have these as our other foundational rules that we could use. Just in these cases, we're focusing on power, product, and quotient as we're learning the chain rule. But you can still have a trig problem that uses the chain rule, or an exponential that uses the chain rule, or a log that uses the chain rule. Okay. So I think the first thing that I want you to do for these problems, so 10 through 15, is to label which rule they're using: power, product, or quotient. And pause me and do that yourselves. Pause me and do that yourself. Okay, so I will now quickly label them. This first one is product. The second one is also product. This is the power rule. This is a quotient. This is a power rule, actually. And this is a product. Okay, so I think the hardest one to tell is that this one is a power and not a quotient. You always want to consider what is the outermost function, and since the outermost function here is actually a power of 1/2, it is very similar to problem 12. So we're always trying to look, what is the first thing we have to do? What are the outer functions doing? Okay. But within these product, power, and quotient rules, we are going to utilize the chain rule that we just learned. So I'll do an example of each of those. I will walk through, what are the more challenging ones? Well, I'll do that one, obviously that one, and then I'll do this one as well. Okay? So let's start off with just the product rule. We have our 2 functions that I will state. I will say, let's use black. I'll say u is equal to x squared, and my other function is v, which is 2x minus 3 to the 4th. So those are my 2 functions. And to do the product rule, we need to find the derivatives. So u prime equals 2x. And now when I'm finding v prime is when I'm going to apply my chain rule. So for finding v prime, I'm going to apply chain rule. Okay? So I'm going to take the derivative of the outside function. I guess I can continue highlighting. So I have my outside function, which is 4, and my inner function, which is 2x minus 3. So the derivative of the outside function is the power rule, and then the inside stays as 2x minus 3, and then I multiply times the derivative of the inside function, and that derivative is 2. So here is where I applied my chain rule, and I'm going to simplify this just a little bit. I'll rewrite this as 8 times 2x minus 3 cubed. So there's my v prime. Now that I've done those two things, I'm just going to do the product rule the same as always. So y prime will equal u times v prime. So x squared times 8 times 2x minus 3 cubed. And then plus v times u prime. So v is 2x minus 3 to the 4th times 2x. We can just do a little bit of simplification. I'll just multiply these terms out. So this is 8x squared times 2x minus 3 cubed plus 2x minus 3 to the 4th. So here is my final answer. Now let's do 13. So 13 is a quotient rule. I can see in the denominator, uses the chain rule. So for quotient rule, I still want to think of my high and my d low. So I will say my d high is the derivative of what's up here. That's 1. Nice and easy. My d low is the derivative of this thing. So this low function I'm going to rewrite as x squared minus 1 to the 1/2, so that I can take the derivative of that easily. So that's my lower function. So when I take the derivative of this, I need chain rule, so I have my inner function is x squared minus 1, and my outer function is the power of 1/2. So that derivative, I bring down my 1/2, and the new power becomes negative 1/2, and the inside stays the same, x squared minus 1, and then I multiply times the derivative on the inside, which is 2x. So I perform the chain rule while taking the derivative of the bottom function. And again, I'm going to simplify that a little. My 2's cancel out, and I'm going to bring this term down because it has a negative exponent of 1/2. The only thing left in my numerator will be x. So I get x over the square root of x squared minus 1. And you can pause if you have a hard time seeing what I did there. Okay, figure out the math. But that is how that would be simplified. Okay. So now that I know my high, my low, my d high, my d low, I can sing my little song, low d high minus high d low over the square of what's below. So in the numerator, I have low d high, which is 1, minus high d low, so that's where this thing comes in, x over the square root of x squared minus 1, all over the square of what's below. So what's below is the square root of x squared minus 1 squared. Just let's do a tiny bit of simplification. This first term will stay the same, so x squared minus 1. When I multiply these two x's, I get x squared over the square root of x squared minus 1. And then in the denominator, my square root and my square cancel out to be x squared minus 1. And we can just leave it like that. Okay. And now an example of the power rule, which we've seen a lot like this, but now we're doing the power rule where the inside function is where my chain rule is. Okay. Or no, yeah, the inside function is my chain rule. So here I have my inner and my outer, like that. Just the way we've done other problems, and I can go ahead and start. So y prime, I bring down my exponent. The new power will be negative 1/2. The inside will stay the same, x over 4x minus 1. And then I need to multiply times the derivative of the inner function. So yes, the inner function is a quotient, which means the derivative of this inner function needs the quotient rule. So for this pink inner function, I have to do low d high minus high d low over the square of what's below. So I will sing my song to help me out. Low d high is 1 minus high d low will just be 4 over the square of what's below. So the lower function squared. And that's the derivative. This thing is going to end up being a huge mess still. So the only thing that's going to be left in my numerator are these terms right here. So I will kind of multiply it out. That's 4x minus 1 minus 4x is the only thing still in my numerator. This 2 is in the denominator. This term gets moved to the denominator because of its negative exponent, so I will rewrite it as x over 4x minus 1. Oops, I forgot my x. So this is the square root of 4x minus 1. There we go. And then this term is still in the denominator, so times 4x minus 1 squared, like that. The numerator is the only thing that I want to simplify. My 4x's cancel out. So this final answer is negative 1 over 2 times the square root of x over 4x minus 1 times 4x minus 1 squared. That's all we need to do. So there's that power rule with the chain rule. Okay. I will leave those other 3 for you to try on your own. So you should pause and try those. After you try it, you can pause this video to check out the work. So 11, 12, and 13, 11, 12, and 15, sorry, are right here. 11, 12, and 15 are the ones you should do on your own, and you should end up with these answers there. So you can pause if you want to get those. Otherwise, I'll just go through a couple of these problems. So we've seen stuff like this before. On the quiz, I gave you a table instead of just listing them out. I feel like the table is easier to read and more likely what you'll see on the AP exam. And on my quiz, I had one similar to 16 and 17. So I already expect you to do ones like those. Those do not require the chain rule, but 18 and 19 do require the chain rule, so I will walk you through those. Okay. So 18, I see that I have a function raised to the power of 3. So f of x is actually my inner function, and 3 is my outer function. So if I'm color coding, f of x is on the inside, 3 is on the outside. So when I do my derivative rule, I take the derivative of the outside, which is 3, and the power changes to 2. The inside is going to stay the same, times the derivative on the inside, which is f prime of x. So here is the derivative of that function, using the chain rule. And I'm supposed to find the derivatives when x equals 2. So I have 3 times f of 2 squared times f prime of 2, and then I will just use the values that are given here. So 3 times f of 2, which is negative 3 squared, times f prime of 2, which is 6. So this is 3 times 9 times 6, which is 18 times 9, which I'm not really sure what that is. 81 times 2, 162, I think. Okay. That's my guess. Yeah. No, 162. Okay. And then let's do this other one. So f of g of x. This is straight up the chain rule, the definition of the chain rule. So the definition of the chain rule, when I have a function in a function, so g is my inner, f is my outer, because I take the derivative on the outside, f prime, the inside stays the same, g of x, times the derivative on the inside, g prime of x. That's just the definition of the chain rule. And now I can fill them in with where x equals 2, so f prime of g of 2 times g prime of 2. G of 2 equals to 3, so this is f prime of 3 times g prime of 2 is negative 2. Remember I'm just getting these values from over here. G prime of 2 is negative 2. So lucky enough, they also told me f prime of 3. It's not lucky, they did that on purpose. They knew we would use f prime of 3. So f prime of 3 is 4, and then times negative 2 is negative 8. So that's how you'll do ones like that. If you needed more practice or you weren't sure from the quiz today, here's how you do 16 and 17 as well. So if you want to look at 16 and 17, 17 is very similar to the one that we had on the quiz. It might be the same answer, I'm not sure. Okay. Anyway, so come to class prepared to apply the chain rule, complete the problems that are not on this video, 11, 12, and 15, and good luck.